All right, check out this next one. LMPQ is a kite, and we are going to go based on the way the appearance looks on this one. I would like to think it's fairly obvious that in this particular thing, which they did tell us was a kite, that these two segments would be the same length in these two. Now, in geometry, we are instructed to never assume that we know anything, because if we have an appearance of congruency, we can't just assume that. I'm going to jump in with this one and say, you know what, these two must be the same in these two. Otherwise, we'd be on this really weird looking assumption that this side is congruent to this side and this side is congruent to that side, and that's just not even gonna look right. Okay, so let's just jump right in with what we do know. Those two are the same, those two are the same. Based on appearance, don't always do that. We did this time. In a kite, you're going to have diagonals that make a right angle. And also, you're going to have a situation where one of the diagonals, and I think it's fairly obvious which one in this particular case, one of the diagonals is bisected. The other one is not necessarily. And I just want to point out some other things. You're going to have lots of right triangles hanging around in here. And with those right triangles, you have the risk of running into the Pythagorean theorem, which is not that scary. It's kind of fun. All right, let's figure out what we have. We have LM, which is equal to x plus 14. And we have LQ, which is equal to 2x plus 1. They're asking us for x and LQ, and you might say, LQ is 2x plus 1. Yeah, let's find out what x is. So we know these two are equal, so let's set them equal to each other. 2x plus 1 equals x plus 14, and we'll subtract 1, we'll subtract x. Cancel, 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 cancel. X equals 13. Haha, good to know. X equals 13. I'm looking for LQ, and so I'm going to take 13 and plug it in right there. So LQ is equal to 2 times x, which is now 13. Well, it always was 13. We just now know it. And that's equal to 27. So 27 centimeters, inches, yards, light years, whatever. Okay, now let's deal with some angles and let's change colors a little bit. MLP, which is way down here, is 23 degrees. 23 degrees. And then they're going to ask a bunch of other stuff. So let's figure out things before we even get to what they're asking. First of all, 90 degrees all the way around here. And in a kite, and it's really hard to articulate this, but in a kite, and you can visualize it, the longest, let's not say the longest, it's not necessarily, it's not always the longest, but this diagonal that bisects the other diagonal bisects the opposite angles. So this is 23, so this is 23. And I have no idea what angle measurement this is, but I know this one is the same. I do know that much. Okay, so let's figure out some other stuff. MLQ is, well, 23 and 23, which I think I know what that is. That'd be 46 degrees. LBM, oh, that's 90, okay. And LMB. Okay, well now we're in a situation where I don't know this angle and it's not staring me in the face in obviousness, but I do know that I have a right triangle with a 23 degree angle here, a 90 degree angle here, and something else that I'm looking for, call it what you want. I'm gonna call it Z, no reason, just feel like it. And I know this, and you don't have to write all this, but this can happen in your head. 23 degrees plus 90 degrees plus Z degrees equals 180 degrees, and this marker is dying, this ink pen. And so we're gonna subtract 90 and 23 from 180, and it is going to give us 67. 67, so Z is gonna be 67 degrees, LMB is 67.